Hello everyone, my name is Hormoz Shahrzad and I'm excited to present EVOTER, Evolution of Transparent Explainable Rule Set, a joint effort with Babak Hodjat and Risto Miikkulainen. This work addresses a pressing challenge in AI, bridging the gap between performance and explainability. Most modern AI models are black boxes. They can be accurate, but we often don't know why they make the prediction they do. This is a serious problem in domains where decision must be understandable, like healthcare, finance, and law. Post-hoc explanation methods like SHAP and LIME try to interpret black boxes, but their explanations are local and case-based. So instead, we ask why not make the model explainable from the start? That's the central motivation for EVOTER, to evolve models that are inherently interpretable, trustworthy, and modifiable. Traditional genetic programming systems evolve rule sets as trees. While trees are technically interpretable, they often become bloated and hard to read. EVOTER takes a different approach. We use a flat list-based grammar which helps maintain simplicity and be extended with three key properties. Time-lag operators help capture patterns in time series data. Feature-feature comparison allow relational reasoning. Exponent and coefficient bring in nonlinearity, enabling the model to capture physical or biological laws. These additional greatly enhance the representation capabilities of transparent models, maintaining human-readable logic. Here's how EVOTER rules look. Each rule is a logical statement. If these conditions hold, then take this action. The grammar allows rich expressions. Condition can include time lags, exponent, comparisons between features, and weights. What's important is that every rule is auditable. Domain expert can look at it and understand why the system made a particular recommendation. Here's a quick glance at EVOTER's flat list-based grammar. Rules are expressed plainly. If condition holds, then action follows. Condition can involve coefficient, comparison, exponent, and time lags. This structure makes model not just interpretable, but also straightforward to expert to verify and refine. Let me show a simple but powerful illustration in the classic cart pull control task. EVOTER evolved this elegant rule: if 0.16 times cart velocity cube is less than 0.87 times pole angle, go left, otherwise go right. Compare the decision surface to a naive Bayes decision tree shown in E or a random forest trained on the same data. Their models are far more complex for their suboptimal performance. EVOTER discovers compact rules that are interpretable and might uncover deeper relations in the feature space. In the real-world case, EVOTER was used to recommend treatment for diabetic patients. Here, two objectives have to be optimized: minimize hospital readmission and maximize favorable discharge outcomes. EVOTER discovered rule set that made treatment decision and outperformed historical prescription in the dataset. More importantly, physician could read the rules and understand the rationale behind each recommendation, which can also be pruned from the redundancies and simplified using LLMs. Here's where EVOTER shines. Transparency enables us to identify potential biases. For example, one evolved rule included patient race as a condition. Doctors could verify whether that inclusion was medically justified or whether it reflected a bias in the data. This level of inspection is almost impossible with black box models. With EVOTER, biases are visible and editable. As it comes naturally with evolution, EVOTER handles multi-objective optimization gracefully. In tasks like diabetes treatment or heart failure prevention, it can discover trade-offs between different goals, such as effectiveness versus cost, while keeping the rules simple and traceable. The comparison with the black box neural network system demonstrates that the transparency cost does not incur a significant cost. There are still challenges ahead. Noise and redundancy. Rule set can get noisy, but we are developing pruning and human-in-the-loop tools for simplification. Scalability. We've created a GPU-based rule evaluator that speeds up evolution by almost 10x. Future directions. We are exploring domain-specific grammars, rule distillation of deep networks, and broader bias auditing. To conclude, EVOTER offers a compelling path forward. It brings explainability into the model itself, not just as an afterthought. It supports rich, powerful logic thanks to its grammar extensions, and it enables experts to understand, trust, and refine the decision process. Across prediction, control, and prescription tasks, EVOTER demonstrates that we don't have to sacrifice performance for transparency. Thank you.